Hi, this is Lakshmanachari, working as Assistant Professor in Department of Cyber Security, Institute of Aeronautical Engineering, Hyderabad. So in this lecture, we are going to discuss about asynchronous data transfer. So in general, we are transmitting the data from one unit to the another unit. That is means we are transmitting information from the source unit to the destination unit. Okay, so data transmission. So we are discussing about the data transmission. So what do you mean by data transmission? So data transmission means transmitting of information from one place to the another place. So that means transmitting information from source to the destination. So that is called data transmission. So this data transmission, it will happen in two ways. That is, one is the parallel data transmission and another one is a serial data transmission. So these are the two types of the data transmissions. So first one is a parallel data transmission. So in parallel data transmission, the sequence of data can be transmitted parallel at a time. So that means all the data we are transmitting at a time. So that is called parallel data transmission. Whereas in serial data transmission, the data is transmitted bit by bit until all the data is transmitted from the source to the destination. So that is called serial data transmission. So these are the two types of the data transmission. So parallel data transmission is a faster. It is a fast way of transmitting, and the serial data is a slowest data transmission technique. Okay, so the data transmission are classified into two types. One is the serial data transmission and another one is a parallel data transmission. So again, the serial data transmission are classified into two types. One is synchronous data transmission and the second one is a asynchronous data transmission. So these are the two types. Okay, so let's see what is the serial data transmission. So in general, the serial data can be transferred from source unit to the destination unit in two ways. One is synchronous and another one is asynchronous. So what is synchronous data transfer? In synchronous data transfer, the source unit and the destination unit shares the same clock pulse, means shares same clock pulses, means same clock pulse is applied to the registers of the source unit and the destination unit. So we are transmitting the information from the source to the destination. So here the source unit and the destination unit, both they are sharing the same clock pulses. So they are sharing same clock pulses. Okay, that means the source is having some registers. So it is having some registers. Similarly, the destination also, it is having some registers. So the registers of the source and the destination units, if they are sharing the same clock pulses, then that is called synchronous data transfer. Coming to the second type, that is asynchronous data transmission. So in asynchronous data transmission, the source unit and the destination unit will not share the same clock pulses. Means a separate clock pulse is applied to the registers of the source unit and the destination unit. So here the clock is not same. They will not share the clock pulse. So see here. So the registers of the source is having some clock pulse. Similarly, the registers of the destination is having another clock pulses. So that means in asynchronous data transfer, the source unit and the destination unit, they are having a separate clock pulses. So then the type of transmission is said to be asynchronous data transmission. So that means here in the asynchronous data transmission, they will not need any synchronization. But whereas in the synchronization data transfer, the both source and the data destination should be synchronized. Then only the data transfer will takes place. But in the asynchronous data transfer, here the synchronization is not required. Suppose if the source is transmitted the data at one point of time. Okay, so the receiver or the destination unit, it doesn't require the same at the same time to receive the data. So at some other particular time, the destination unit can receive the data. But in the synchronous data transmission, the data transmission by the source unit and the data received by the destination unit should happen at the same time. So that is called synchronous data transmission. But in the asynchronous data transmission, so they will have the data transmission will take place at different time intervals. So that is called asynchronous data transfer. So in asynchronous transmission, binary information is sent only when it is available, and the line remains ideal when there is no information to be transmitted. Serial asynchronous data transmission technique used in many interactive terminals employ special bits that are inserted at both ends of the character code. With this technique, each character consists of three parts. So start bit, character bits, and stop bits. So every character of the character in the asynchronous, it is represented with three types of bits. One is the start bit, character bit, and the stop bits. Okay. So the convention is that the transmitter rests at the one state when no characters are transmitted. So when the transmitter is not transmitting any data, then the output of the transmitter is set at logic 1 state, logic 1. So logic 1, it indicates that it is an ideal state. That means no data is transmitting. So the first bit called start bit is always 0. So the first bit of the character bits character is always 0. So that indicates that that is the starting of the data, starting of the character bits, starting or beginning of the character bits. And the last bit is called stop bit. So the stop bit it indicates that that particular character has ended. So that stop bit is represented with 1 always. So here you can see the example of this format. So see here. So this is a start bit. So start bit is always 0 and stop bit is always 1. This is 1 stop bit. And in between the start bit and stop bit, we have 8 bits of information. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this 8 bits, it constitutes a character. So in this way, we are transmitting the data as characters from the source unit to the destination unit in serially. Okay. So the transmitted character can be detected by the receiver from the knowledge of the transmitter rules. So when a character is not being sent, the line is kept at one state. The initiation of character transmission is detected from start bit, which is always 0. So the starting of the character is detected by the bit 0, because always the 0, it represents the starting of the character, and character bits always follow the start bit. After the last bit of the character is transmitted, the stop bit is detected when the line returns to one state for at least 1 bit time. And coming to the asynchronous data transmission. So already we have seen what is asynchronous. So in asynchronous data transfer, the source unit and destination unit, they will use a separate clock, or they use their private clock for data transmission. So that is a asynchronous data transfer. So if the registers in the interface share a common clock with the CPU registers, the transfer between the two units is said to be synchronous data transfer. In most cases, the internal timing in each unit is independent from the other unit. So that each uses its own private clock for internal registers. Then that type of data transmission is called asynchronous data transmission. So see, so asynchronous data transfer. So in a computer system, the CPU and I/O interfaces are designed independently of each other. So in a computer, so for the computer, we are connecting several I/O devices with the CPU. So that means the CPU interfacing, the CPU and the I/O interfacing. So these two units are independent units. Independent units. Okay. So independent units means they are using a separate clock for them. So that's why it is called asynchronous data transfer, because the CPU uses different clock and I/O interfaces use different clock. So that means this is called asynchronous data transfer. When the internal timing in each unit is independent from other, and the registers in interface and the registers of CPU uses one private clock. The asynchronous data transfer can be used to coordinate the speed and its timing characters. So the asynchronous data transfer between two independent units require that control signals transmitted between communicating units, so that the time can be indicated at which they can send the data. And this asynchronous way of data transfer, it is achieved using two methods. The first method is the strobe control, and the second one is the handshaking. So using these two methods, we can achieve the asynchronous data transfer. So first method is a strobe pulse. So what is strobe pulse? So strobe pulse is a control signal. It is a control signal, and that is supplied by one unit to indicate the other unit when the transfer has to occur. So the strobe may be activated by the source or the destination unit. Okay. So this strobe pulse, it is generated by either the source unit or the destination unit. So either way, we can generate the strobe pulse. So first one is the source initiated data transfer. Source initiated data transfer, and the second one is the destination initiated data transfer. So based on the strobe pulse generated, then this data transfers are classified into two types. So first one is the source initiated data transfer, and the second one is the destination initiated data transfer. So what is a source initiated data transfer? So see here. So the data bus carries the information from source unit to the destination unit. So here you can see the source unit and the destination unit. Okay. So the source unit will generate the data, and the data we are transmitting to the destination unit through the data bus. So the strobe is a single line. So okay. So see here. So this is a strobe pulse. Strobe pulse is a single line. The signal on this line informs the destination unit when the data word is available in data bus. So when the source unit is generated the data, then the data will be placed in the data bus. Okay. So after placing the data in the data bus, the source unit will generate a strobe pulse after a slight interval. After a brief delay, the source unit will generate a strobe pulse to the destination unit. So whenever the destination unit it receives a strobe pulse, it indicates that the source unit is placed a valid data in the data bus. So that is the meaning of the strobe pulse. So the same operation you can understand with the timing diagram. So timing diagram is it describing the operation with respect to the time. So see here. So the first is the source unit will generate the data, and the data will be placed in the data bus. Okay, at this point. Okay, so what will happen after a brief period? So that means after some delay, then the source unit will generate a strobe pulse. So here it is a strobe pulse generation. Okay, and it is applying to the destination unit. Whenever the destination unit it receives the strobe pulse, it can indicate that the source unit is placed a valid data in the data bus, so that the destination unit will read the data which is available in the data bus. So after that, the strobe pulse will when the strobe pulse is disabled after a brief delay, then the source unit will stops keeping the data in the data bus. Okay, so this is a source initiated data transfer. So here the source will generate the strobe pulse. So that's why it is called source initiated data transfer. Now coming to the second type, that is a destination initiated data transfer. Okay, so see here. So in this case, the destination unit activates the strobe pulse. So here you can see this is a source unit and this is a destination unit. So see, so destination unit will generate a strobe pulse first. So first the destination unit will generate a strobe pulse. Okay, strobe pulse is generated and it will be given to the source unit. It is given to source unit. So whenever the source unit is received a strobe pulse from the destination unit, then the source unit will place a valid data in the data bus. Valid data in the data bus. Okay. So this is a destination initiated data transfer. But here the main disadvantage with this method is the source unit that initiates the transfer has no way of knowing whether the destination unit has received the data or not. So that is a main drawback with this strobe method. Okay, so that is a drawback. So in order to overcome that drawback, we are going for the handshaking method. That is a second type of the method. Okay, so we are going for the handshaking method. So in handshaking method, we are removing the this drawback which is present in the strobe method. Okay, so in strobe method, so the source unit it doesn't know whether the destination unit has received the data or not. So the source unit it doesn't know whether the data is reached the destination unit or not. So in order to overcome the drawback, we are going for the handshaking method. Okay. So see here. So what is handshaking? So the handshaking method, it solves the problem raised in strobe method by introducing a second control signal that provides a reply to the unit that initiates the transfer. So that means we are providing one more control signal, okay, in the handshaking. So the receiving unit responds with another control signal to acknowledge the receipt of data. So see here. So when we have a source and a destination. Okay. So when the source unit it sends the data to the destination, whenever the destination unit receives the data, then the destination unit will send an acknowledgement to the source. It is an acknowledgement, so that the source can understand that the destination unit has received that data. Okay, so this is the handshaking method. Okay, so this in the data transfer can be occurred as source initiated transfer, and the second one is a destination initiated transfer. So again here also two types are there. One is a source initiated transfer and the second one is a destination initiated transfer. Okay, so first one is a source initiated transfer using handshaking. So see here, the two handshaking lines generated by the source and destination respectively are. So see here, this is a source unit and this is a destination unit. Okay, so see here. So first so here two control signals are there. One is a data valid and another one is a data acceptor. So what is data valid? Data valid is generated by the source unit to the destination unit to inform whether there are valid data in the bus. So this data valid, it is informs the destination unit that the source unit is placed a valid data in the data bus, so that the destination unit starts reading the data from the data bus. And second one, data acceptor. Data accepted. So once the data valid is received by the destination unit, the destination unit it come to know that valid data is placed in the data bus, so that the destination unit will read the data which is present in the data bus. So once the reading of the data is completed, then the destination unit will send a data accepted signal to the source unit. Okay, so once the source unit it receives the data accepted signal, then the source unit it stops placing the data in the data bus. So that is a source initiated transfer using handshaking. So the same you can understand with the timing diagram. So first the source unit will place the data in the data bus. Then after a delay, after a brief delay, the source unit will generate a data valid signal to the destination unit, so that the destination unit will know that the valid data is present in the data bus, so that the destination unit will read the data from the data bus. After that, the destination unit will send a data accepted signal to the source unit, so that the source unit will stop the keeping the data in the data bus. So this is the sequence of operations. So let's see some sequence of events. So whatever we have discussed, so that we have shown in as a sequence of events. So this is a source unit and this is a destination unit. So first the source unit will place the data in the data bus. Okay, so and after that the source unit will enable the data valid. Okay, so after that the destination unit will accept the data from the bus. Then the destination unit will enable the data accepted signal to the source. Okay, then the source unit will disable the data valid signal and invalidate the data which is present in the data bus. And the destination unit will disable the data accepted and ready to accept the data. That means it will comes to the initial state again. So again it will be go to the starting source unit. Again the source unit has to place the data on the data bus and the source unit has to generate the data valid signal. So this operation will be continuous until all the data is transmitted from the source unit to the destination unit. So these are the sequence of events. So same whatever we have discussed. We have so first a source unit initiate the transfer by placing data on the data bus, and it will enable the data valid signal. And after that, the data accepted signal is activated by the destination unit. After it accepts the data from the bus, then the source unit will disable the data, and then it will disable it also deactivates the or invalidates the data in the bus. And next, destination unit disables the data accepted signal and the system goes into initial state. And coming to the destination initiated transfer using handshaking. So just before we have seen source initiated. Now we are going to discuss the destination initiated data transfer. So two handshaking lines in this scheme are data valid and ready for data. So these are the two signals we are using. So in previous one, source initiated transfer using handshaking, we have seen two control signals. One is a data valid. Next, data accepted. So these are two we are using in source initiated data transfer. In destination initiated transfer, we are using data valid and the ready for data. So the source unit in this case doesn't place data on the bus until it receives a ready for data signal from the destination unit. So you can understand with a diagram. So this is a block diagram, this is a source unit, and this is a destination unit. So in previously source initiated, the source unit will place the data in the data bus, but here not like that. So here first the destination unit will send a signal to the source unit, that is ready for data. So this is the first signal. So the destination unit first it will generate a signal that is ready for data to the source unit. So whenever the source unit it receives the ready for data, it indicates that it can understand that the destination unit is ready to accept the data, ready to receive the data. So that the source unit will place a data in the data bus. The source unit will place a data in the data bus. After placing the data in the data bus, the source unit will generate a data valid signal and it will be given to the destination unit. So that the destination unit will come to know that a valid data is placed in the data bus, so that the destination unit will read the data from the data bus. So that is a sequence of operation. Okay. So the same you can see in the timing diagram. So first ready for data signal will be generated by the destination unit. So ready for data. After that, the source unit will place the data in the data bus. This one. So this is a first, this is a second sequence, and after third. So the source unit will generate a data valid. Okay, so this is a destination initiated transfer using handshaking, and this is a sequence of steps. So first the destination. So here the operation starts with the destination unit. So first the destination unit will generate ready for data, ready to accept, ready for data signal to the source. Then it also enable ready for data. Then next the source unit will place the data on the data bus and it generates a data valid signal to the destination unit. Then the destination unit will accept the data from the data bus and it will disable the ready for data. Then the source unit will disable the data valid, then invalidate the data on the data bus, and again then the sequence of operation starts with the destination, because here in the destination initiated transfer the operation starts with the destination unit only. Okay, so the source unit will not transmit any data until it receives a ready for data signal from the destination unit. Only it transmits the data if it receives a ready for data signal from the destination unit. Okay. And coming to the advantages of asynchronous data transfer. So the sender can send data at any time and receiver can receive it at any time. So this is a main advantage with the asynchronous data transfer, because here no need to transmit the data by the sender and receives the data by the destination unit at the same time. Okay, so at different intervals the source can transmit the data and similarly the receiver can receive the data. Okay, so here there is no need of any synchronization. So this is a first advantage of the asynchronous data transfer. But whereas in synchronous data transfer, so both the source and destination has to be synchronized. That means whenever the data is transmitted by the source unit, at the same time the receiver has to be received the data from the source. And the second advantage is it is a cheap and easy to implement. So it is cheap and easy to implement. That is no clock sharing. So because already we have seen in the asynchronous data transfer, the source unit and the destination unit, they are using a separate private clocks. So that's why they are cheap and easy to implement. No need to be synchronized. And the third one is it is more flexible because the sender can transmit the data at one time and the receiver can receive the data at some other instant of time. So that's why it is more flexible, and devices can exchange information at their own pace, and receiver don't have to wait for the next packets as each packet is complete, and the sender requires no primary storage device to transmit the data. So these are the different advantages of the asynchronous data transfer. So in this lecture, we have seen what is a data transmission and the different types of the data transmission, and also we have seen different types of serial data transfer. So in serial data transmission, we have two types. One is a synchronous serial data transmission, and another one is a asynchronous serial data transmission. So in asynchronous serial data transmission, we have seen different types. So in asynchronous data transmission, the data transfer can take place using two methods. One is a strobe pulse method and another one is a handshaking method. So we have discussed these two, and finally we have discussed the advantages of the asynchronous data transfer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.